Esteemed executives, I am here to provide a briefing on a significant development in the field of generative artificial intelligence that holds considerable implications for our organization's technological initiatives. The focus of this briefing is recent research addressing the critical challenge of reducing hallucinations in large language models, ostensibly where these models generate untrustworthy or incorrect outputs. This issue is particularly pressing when deploying AI systems for generating structured outputs, such as workflows represented in JSON format, where accuracy and reliability are paramount. Recent advancements have introduced a novel approach known as retrieval augmented generation, or RAG, which has shown promise in mitigating these hallucinations. This technique enhances the performance of language models by retrieving relevant information from a dedicated knowledge base prior to generating responses. By grounding outputs in factual data, RAG significantly reduces the risk of generating incorrect or non-existent references, thereby improving the trustworthiness of AI-generated content. Key insights from the research highlight the effectiveness of the RAG approach. The implementation involves a two-stage system comprising a retriever and a language model. The retriever is trained using a Siamese transformer encoder architecture, enabling it to efficiently search and retrieve pertinent information from extensive knowledge repositories. This retrieved information serves as a factual foundation for the language model, which is responsible for generating the final structured output. The language model component utilizes fine-tuned versions of the star-coder-based model architecture. Various model sizes were tested, with the 7 billion micrometer version emerging as the optimal choice due to its balance between performance and computational resource requirements. This model size offers a practical solution for enterprise applications, allowing for high-quality output without the need for excessive computational power. Experimental results from the research are compelling. The use of RAG reduced the occurrence of hallucinated steps and generated outputs from over 20% to less than 7.5%. This substantial decrease underscores the effectiveness of grounding language model outputs in retrieved, relevant information. Moreover, the RAG approach demonstrated strong generalization capabilities to out-of-domain settings, which is crucial for applications that encounter a wide variety of input scenarios. An important finding is the realization that pairing a well-trained, efficient retriever with a smaller language model can achieve performance levels comparable to larger, more resource-intensive models. This synergy allows for the deployment of powerful AI systems that are less demanding on computational resources, offering cost savings and increased scalability for widespread application. The research also delves into error analysis to identify the sources of remaining inaccuracies. Both the retriever and the language model contribute to errors when they fail to retrieve relevant information or misinterpret the retrieved data. By understanding these error patterns, strategies can be devised to further enhance system performance. Such strategies include improving retriever training methods, augmenting the knowledge base, and refining the language model's ability to process and integrate retrieved information. From an engineering perspective, the findings have influenced key design decisions. Considerations regarding training batch sizes have implications for model convergence speed and resource utilization. Deployment strategies have been adjusted to optimize the balance between performance and operational efficiency, ensuring that AI systems can be scaled effectively without compromising on quality. Ethical considerations are also a central theme of the research. The importance of transparency and user awareness is emphasized, particularly in implementing post-processing measures that flag potentially hallucinated outputs. By alerting users to areas of uncertainty, the system fosters trust and allows for informed decision-making. This approach aligns with ethical best practices and positions the organization as a responsible leader in AI deployment. Based on these insights, several actionable recommendations are proposed. Firstly, integrating retrieval augmented generation into our AI systems should be a priority. By adopting RAG, we can enhance the accuracy and reliability of structured outputs, which is essential for applications in workflow automation, data analysis, and decision support systems. This integration will address current limitations and improve overall system performance. Secondly, investing in the development and maintenance of comprehensive knowledge bases is crucial. The effectiveness of the RAG approach is directly tied to the quality of the information available for retrieval. Ensuring that our knowledge repositories are extensive, up-to-date, and accurate will maximize the benefits of grounding language model outputs in factual data. Thirdly, it is advisable to optimize our language models by adopting smaller, efficient architectures without sacrificing performance. Utilizing models like the 7 billion parameter version of Star Coderbase can reduce computational costs and resource demands while maintaining high-quality outputs. This strategy supports sustainable AI practices and allows for more efficient scaling across different applications. Additionally, implementing rigorous error analysis protocols will be beneficial. Regularly assessing the performance of both the retriever and the language model will help identify areas for improvement. Techniques such as enhancing retriever algorithms, refining training data sets, and applying advanced prompt engineering can reduce error rates and improve output accuracy. Moreover, incorporating user feedback mechanisms into our AI systems will enhance their adaptability and responsiveness. By enabling users to report inaccuracies or provide input, the system can learn and evolve over time, leading to continual performance improvements and increased user satisfaction. Finally, upholding ethical standards in AI deployment is imperative. Implementing transparency measures, such as flagging uncertain outputs and providing confidence levels, will build trust with users and stakeholders. This practice not only enhances the user experience, but also aligns with regulatory requirements and ethical guidelines governing AI use. In conclusion, the adoption of retrieval augmented generation represents a significant opportunity to advance our organization's AI capabilities. By mitigating hallucinations in language models, we can deliver more accurate, reliable, and trustworthy AI solutions. The proposed recommendations offer a strategic pathway to integrate these advancements effectively. The next steps involve assembling a cross-disciplinary team to evaluate the feasibility of implementing RAG within our existing infrastructure. This team should develop a detailed plan outlining the resources required, potential challenges, and timelines for integration. A pilot program could be initiated to test the approach in a controlled environment, allowing us to gather data and refine the system before full-scale deployment. Embracing these innovations will position our organization at the forefront of AI technology, enhancing our competitive advantage and delivering superior value to our clients and partners. By combining technical excellence with ethical responsibility, we can foster trust and establish ourselves as leaders in the rapidly evolving landscape of artificial intelligence. Thank you for your attention. I welcome any questions you may have and look forward to discussing how we can collaboratively implement these advancements to achieve our strategic objectives.